So I have a nice little picture here with everything labeled for you. So I've got a quadratic, which also is known as a parabola. I'll write that out for you. My pen's going a little wackadoodle. There we go, parabola. Looks like my daughter wrote it. That's okay. All right, so our quadratic equation, our function, has a lot of parts to it. You have your x-intercepts here, which are also known as, these have a lot of different names, solutions, x-intercepts, roots, and you have your vertex, which is your max or min, depending on which way it's facing. And then you have your y-intercept, which is where we are touching the y-axis. Oh, another name for x-intercepts are zeros, which that's where x is equal to 0, so that's why it's called that. Your axis of symmetry is exactly what it sounds like. It's a line of symmetry, so that's where you're going to fold it in half. It's always equal to the x value of the vertex. So anything there that you think would be helpful, go ahead and write that down. All right, I want to work through some examples. Something that will be helpful to do is get a problem in standard form. We are going to use our algebra skills to get it in standard form. I'm just going to move everything to the left. So I have a positive 6x and I have a positive 2x squared. So I'm going to subtract both of those. That's going to allow me to move them to the left. And you really could just move everything to the right. It doesn't matter. So my standard form, y equals if we have 3x squared minus 2x squared, that's going to give me a 1x squared. When I subtract that, we put this back. 6. So there was another x squared term over here, so we were able to combine those. There's only one x term, so that's going to shift over here, and then I only have the one constant. So this would be standard form. I'm putting the highest power first, then my next highest power, then no power. So it's just going in order. Now we want to know if that is a max or min. We're going to look at the value in front of the x squared. There's really nothing there, but technically there is something there. There's a 1. That 1 is positive, and when you have a positive a value, your parabola is going to face upward, which means my vertex is a minimum. Now to find the zeros, if you are strong with factoring, I'm going to quickly go over factoring, then you can use factoring to find zeros if it can be factored. If it can't be factored, I'm going to have some other options for you in other videos. So you may recall when you are factoring a trinomial, you set up 2 sets of parentheses, and you want to think, what can I multiply to get 5, and what can I add to get -6? And we really don't have a lot of options for multiplying to get 5. It's just 5 and 1, but it's a matter of what signs will I have. Well, if I do a -5 and a -1, when I multiply those, I am going to get a positive, and when I add them, I am going to get the -6. So this would be the correct way to factor it. Now, I'm really not too worried about your factoring skills because, like I said, I'm going to show you another option. But if you know how to factor and you feel good about it and you want to use it, I don't have a problem with it. So the main thing I really want you to know is that the relationship between factors and zeros, they're opposites, because I'm going to set x minus 5 equal to 0. and I'm going to add that 5 over. So that's going to give me x equals 5, and then x equals 1. And I'm just putting it in these little brackets to show the solution set. So if we were going to graph or sketch this parabola, it would actually go through 5 and 1. If you're ever looking at a graph of a quadratic and you see it going through a value, you can easily write the factor. So if I have a 0 of 5, the factor is x minus 5. If I have a factor of x minus 5, the 0 is 5. If this said x plus 5, then it would be negative 5. Let's look at vertex form. So one of the reasons I really like vertex form is because it's super easy to get a nice sketch of it. So I want to show you how to do a lot of the same stuff that I just did. You really have a lot of freedom in this unit to do things the way that you want to do it, the way that it makes sense to you. So if you like working from a certain form, you can do that. Okay, one thing that we can look at is this negative. That's going to tell me that my vertex is a maximum. So my parabola is going to be upside down. The other thing is that this is giving me the vertex. I don't have to do any work. That's one thing that's kind of hard to find from standard form. So vertex form is really helpful if you want to know the maximum or minimum. And as we get into some application, that's going to be helpful. So your vertex form is x minus h squared plus k. So when you are finding the vertex, it is hk. If your equation has a minus value, then that's going to be the h value. But you'll notice that this says plus 3. So when I'm writing my vertex, it's actually going to be negative 3. And then I've got my plus 5. That actually matches up, so plus 5. If you are familiar with transformation rules, this goes right along with that. If you're not, that's totally fine. You can still find the vertex without knowing that. Just compare it to your vertex form, minus h. If this isn't a minus, then we're going to make it a subtraction symbol in our vertex. So one thing I could do is if I want to get a sketch, I can go over left 3 and then up 5. And I can plot that point. Left 3, up 5, that's my vertex, and it's facing downward. Now, where it's actually going through the x-axis, I'm going to actually have to do a little bit of work. If I want to know the zeros, I'm going to have to set this equal to 0, and I'm going to solve. With any function, whether it's linear or quadratic, if you want to find the x-intercepts, you need to set y equal to 0. And if you want to find your y-intercept, we need to set x equal to 0. So let's find our x-intercepts. I'm going to subtract 5. Remember, we want to do the opposite. Then I'm going to divide by this negative to get rid of that. So I will have x plus 3 squared equals 5. So I had a negative 5, but I divided by negative 1, so that made it positive. I'm going to get rid of this squared by square rooting, so that's going to be the opposite. Now, whenever you take the square root, there's going to be a plus or minus. So I have x plus 3 equals plus or minus the square root of 5. And final step, I'm going to subtract 3. So I would have 2 zeros. One at 3, one at negative 3 plus radical 5. And one at negative 3 minus radical 5. We're going to focus on getting these solutions a little bit more later on, but that's just a quick rundown of what you would do. Now, if you can simplify the square root of 5, go for it. Like if it was the square root of 25, that's fine. But in this case, I'm just going to leave it because I can't simplify that. So those would be my 2 zeros. So that means I would have a 0 to the little left of negative 3, and then a little to the right of negative 3. So that's going to give me those values. The other thing we could do is find the y-intercept by plugging in 0 for x. But the main thing I really want you to take away from the vertex form is how to get that vertex. And so that's going to be basically when you're doing the opposite and then the same, that's giving you that coordinate point. Make sure you know that if this is negative, that your parabola is going to face downward and that you have a maximum. All right, let's look at some application with the vertex. So the importance of the vertex is that that's going to give us the maximum or the minimum. So in this case, what is the maximum profit? We can see that the y-axis is our profit. So when I'm looking at my vertex, the y value in this case is a little over 6,000. So whatever our y value is there. And then our input is about $35. So when you're looking at that vertex, it's giving you how much money it will take to get that maximum profit, or maybe how many items you have to sell, or if you're throwing a ball, how many seconds does it reach to maximum height. So that's how you interpret the vertex.